Don't forget to subscribe and ring that bell.
Hey, what you doing? I see you're back, and that is good news. And if you're sitting there like, I've never really watched one of your videos before, so don't be creepy, Visca. Well, then, you know what? Welcome, and, you're right. I'll stop being creepy. Okay, welcome if this is your first time, and welcome back if you've been here before. We are going to continue the 2018 practice exam that College Board put out, 4 years ago for the AP Calculus AB course. We are going to do multiple choice questions 11 through 20. The previous video were problems 1 through 10. And section 1, part A, we will continue. No calculator, but so what? We're good at what we do. Yes, you're good at what you do. Now, follow me so you get notifications when I put up videos in the future, like the videos that follow this one for this exam. Like the video that helps me, and leave a comment if there's an exam that you want to see that I haven't done yet. Let's start. Number 11 says, let f be the function defined above. It's a piecewise function because it is a function given to us in 3 pieces. What is the integration of f of x from -1 to 1? All right, what I notice specifically about the function that's given to us is it splits at 0. And what do I mean? Well, highlighter, I love you. I'm going to use x squared anytime my x is less than 0 for negative numbers. I'm going to use x squared, okay? Anytime my x is negative, I'm using x squared. I'm going to use -1 anytime x is actually 0. And anytime x is positive, I'm just going to use the equation f of x equals x. All right? And what you should recall is that integration is the same thing as area under the curve. Okay, so I need to find the area under the curve from -1 to 1. However, if this splits at 0, in my interval between my upper and lower bound, in between the upper and lower bound is the split 0. What do I mean? All right, if I were graphing this, here's -1, here's 0, and here's 1, all on the x-axis. My function, I don't care if it curves and goes straight. If I just have a function like this, that's f of x. Okay? Anytime x is less than 0, okay, from here to here, I've got to use my function x squared. The area under the curve means I integrate x squared, but from -1 to 0. Anytime x is greater than 0, I'm going to use my function x. So from 0 to 1, I'm going to use my function x. To get that area, I've got to integrate that. And those bounds are from 0 to 1. So that's what I'm going to do. You may say to yourself, well, what about this? Okay, that's just right at 0. That's not an area. That's a straight line. You won't get an area there. And I'll explain more in a minute about why we don't need that as we set up our equation to solve this, okay? Or we set up our work. So let's integrate this area right here. I'm going to integrate x squared dx, don't forget that dummy variable, from -1 to 0. I've got to add that, okay, to the integration. We're doing this now of x from 0 to 1. Don't forget that dummy variable. Now, if I wanted to, and I'm going to speak more about this right now, why we don't use it, okay, I can integrate -1, okay, I can add that integration, but what are my bounds? It starts at 0, and it ends at 0. What happens anytime our bounds are the same? The value ends up being 0. So I really don't need that at all, okay, so we're not even going to put that in there. I think the visual on the graph is enough, but for those of you that are still curious. All right, so now all we got to do is do our work. Let's go here. So if I integrate x squared, I get x cubed over 3. I want that from -1 to 0. Love throwing zeros into these things. And I'm going to add that to the integration, okay, of x, which would give me x squared over 2 from 0 to 1. Again, love throwing in them zeros. Let's start with the left side. Okay, 0 cubed over 3 minus -1 cubed over 3. All right, plus, to the right side, it's 1 squared over 2 minus 0 squared over 2. All right, well, here we go, kids. 0 minus, this is going to still be -1 over 3. That's like a positive third. When I subtract a negative, it's like a plus. I'm going to add, okay, well, this is 1/2 minus 0. So I'm adding 1/2. 1/3 plus 1/2. Well, let's make these have common denominators. I'm going to change 1/3 to 2/6. I'm going to change 1/2 to 3/6. That's 5/6, and we're done. And let's see what choice that is. 5/6. Choice A. Pretty simple one to start. Number 12 says, given that 3x minus tan of y equals 4, what is dy dx in terms of y? Okay, let's break her down, people. We have this equation. We need to find the derivative in terms of y, which means there's going to be a y in our answer. If we look at our answers below, okay, all of our options, there's a y in it. Okay, so there's going to be a y in our answer. That's fine. All right. I'm going to have to do this implicitly. I cannot rip away the y. I mean, I can try, and I probably can, but it will just be a nightmare. So what we're going to do is do this implicitly, meaning anytime I take the derivative of an x, I do it like I normally would. Anytime I take a derivative of a y, I need to write dy dx right next to it. So let's begin. The derivative of 3x is just 3 minus the derivative of tan of y. That is secant squared of y times the derivative of the inside, chain rule. The derivative of y is just 1 dy dx, okay? Equals the derivative of 4 is 0. Now, notice our answers, they're all dy dx equals, right? Which means I want to get this bad boy alone. That's the whole purpose. Now, this is a good question that tests you on trigonometry. 1, on the derivative of tangent, and 2, just knowing your trigonometry facts, I guess I'm going to say. I ain't no good at English. So, let's go. Let's go. First, we're going to subtract 3 from both sides. Negative secant squared of y dy dx. Okay? Let's remember, we still want to get this alone. And that equals -3. So I'm going to divide both sides at this point by negative secant squared of y. Divided by negative secant squared of y. Gadoosh, bye-bye. I now have dy dx equals. A negative divided by a negative turns out to be positives. And I've got 3 over secant squared of y. Here's the issue. None of my answers have secant squared in them. So when I said you need to know your kind of rules and facts about trigonometry, this is another one. Besides the derivative of tangent, you need to know your reciprocal functions. Whatever do you mean, Visca? Well, there's sine, there's cosine, and there's tangent. There's, I get it, there's cosecant, there's secant, and there's cotangent. But you got to understand that secant is considered a reciprocal function of cosine. Same way cosecant is considered a reciprocal function of sine. So secant of, let's say, y, in our case, we have a y here. That's the same as saying 1 over cosine of y. And guess what? If the secant here is squared, the cosine here is squared. I am going to substitute in for secant squared 1 over cosine squared. Okay, you need to know that. So I've got 3 over 1 over cosine squared of y. Okay, I look at my answers and I still don't see that. There's only one that has a fraction, and there is no trig in that whatsoever, so I'm just going to get rid of this. So I got to make it so I don't have a fraction anymore. And what I'm going to do at this point is multiply both the top and bottom by cosine squared of y. This will cancel, and now the bottom goes bye-bye. What I do to the bottom, I also need to do to the top. So when everything is all said and done, I got 3 cosine squared of y. That's my answer, and that looks to be choice B. There you go. 12 is B. We're looking good. And again, you need to know your trig facts. They will come up on this exam. 13 states. For time t greater than or equal to 1, the position of a particle moving along the x-axis is given by P of t equals a square root of t minus 2. Okay, pretty simple. Position. At what time t in the interval between 1 and 16 is the instantaneous velocity of the particle equal to the average velocity of the particle over that interval from 1 to 16? All right, here we go. Ready? The instantaneous velocity, well, that's just the derivative of position. Okay? That's the velocity at one point, instantaneous velocity. The average velocity, that's our change in y over change in x. That's between 2 points. Okay? This is 1 point, and this is 2 points. It wants to know what value of t between 1 and 16 are those the same. So I got to take the derivative of p and set it equal to, well, instead of saying change in y over change in x, I guess I'll say my change in time over my change in p of t. All right. So what value of t is going to make these equal? This is like the average value, not average value, because that's for integration. The intermediate, the average for derivatives, value of derivatives. I don't know. There's just always 1 point. If you have a continuous line, okay. Forgive me for forgetting what the theorem is. I know like 17,000 of them, and it's terrible. But if you have a continuous line between 2 points, there has to be somewhere a point in between your two endpoints where the slope at that point is the same as the average. So they're really just testing you on that, your knowledge of that. So first of all, let's do, I was going to say the easier part, but I think they're both pretty easy. Let's do this side right here. Derivative of the square root of t minus 2. First of all, I'm going to say t to the 1/2 minus 2. That's what p of t really is. Okay, it is always easier to find derivatives when we have exponents. All right, so I'm going to bring down my 1/2, multiply it times t, and subtract 1 from the exponent, negative 1/2. The derivative of 2 is just 0. Bye-bye. Let's clean this up because we're going to have to solve for t on this side. We're going to bring the t down. So this is going to go into the denominator to make my exponent positive. So I have 1 over 2t, the positive 1/2. And I'm going to take that even one step further. I'm going to make that into a square root again. Now that will be really easy to solve for. This is the derivative of p of t. Sorry, that was a mess. That needs to be set equal to whatever this is. Okay, so let's do that. Well, my change in time goes from 16 to 1. If you didn't know that, that's the interval they give us here. All right, which means I need to find p of 16 and subtract p of 1. Okay, remember, my p was a square root of t minus 1. So if I put a 16 in, I hate when the board does that. When I put a 16 in there, the square root of 16 minus 1 is 4 minus 1, which is 3. Okay, So now I've got 3 in the top. The bottom here, 16 minus 1 is 15. Now I got to throw a 1 into this t. So the square root of 1 minus 1 is 1 minus 1, which is 0. So 0. I end up with 3 over 15, which reduces to 1 over 5. Right? This thing right here is 1 over 5. I'm going to set that equal to this right here, which is this. Okay, so let's get a little crazy, people, here. So 1 over the square 2 square root of t equals 1 over 5. Oh, really easy now. If the tops are the same, that means the bottom's got to be the same. So I'm just going to take 2 square root of t equals 5. And I'm just going to use opposite math. Let's start by dividing by 2. And now I've got square root of t equals 5 halves. All I've got to do is just square both sides. The square gets rid of the square root. And when I square this side, I get 25 over 4. Well, technically, 25 goes, 4 goes into 25 6.25 times. It's 6 1/4. Okay? And 6 1/4 is definitely between our interval. It's in our interval, so it's 25 over 4. Right, number 14. None of the problems, 11, 12, or 13, have been quick. This one's been, it's going to be a little bit quicker, but again, the explanations come along with it. Okay? So 14 reads, if f is a differentiable function and y equals sine of f of x squared, what is dy dx when x is 3? All right, so basically, what is y prime? Derivative of y at an x value of 3. So let's first find the derivative of y. We've got to do the chain rule twice. What do I mean? Oh, man, these highlighters. I start by doing the derivative of the outside. The whole inside stays the same. All right, so let's start with that. The derivative of sine is cosine. That inside stays the same. Okay? Now I've got to do the derivative of the inside. But guess what? When I do the derivative of this, I'm only going to do the derivative of the outside. This inside will stay the same. Okay? So multiply times that. So I don't know what f is in terms of an equation. I can't find the derivative of a term, but I know the derivative of f is just f prime. Okay, that's the derivative of this. The inside is going to stay the same. Now, I take the derivative of the inside, which is 2x. So we're going to do the chain rule twice there. All right, so let's just clean this up, and we'll throw a 3 in there afterward. Or we can throw a 3 in there now. Let's just do that. So I have the cosine of f of 3 squared, because I'm throwing a 3 in for x, times f prime of 3 squared, again, 3 for x, times 2 times 3. All right, so that's the cosine of f of 9 times f prime of 9 times 6. In multiplication, order doesn't matter, and you should be far enough into this that you know they always put trig last. So they put cosine of f of 9 would be last. And they always put just individual numbers first, 6, which would mean this would be next, f prime of 9. Okay. Anyways, in multiplication, order doesn't matter. The only option that I have that has these 3 in them, the 6, the f prime of 9, and the cosine of f of 9, is the last one right here, D. Your answer should be D. Ooh, boy. You know how I feel about graphs and tables and charts? I love them. I love graphs and tables and charts. Oh, my. 15 reads, the graph of g prime. The first derivative of the function g consists of a semicircle. Woo! semicircle right here. Radius of 2. 2 is my radius. Okay, and 2 line segments. 1 line segment, 2 line segments. Okay, as shown in the figure above. If g of 0 is 1, what is g of 3? My goodness. The fundamental theorem of calculus, technically it's part 2 of the fundamental theorem of calculus, states that if I take the integration of f of x from 2 bounds, that would give me f of b minus f, that's a capital F of a. Meaning I would come up with the original equation and put the bounds in there and subtract them. I mean, we've been doing this. We've already been doing this, okay? We did this right here. See these problems right here? Oh, that's going to be a nice purple. See these right here? Didn't we throw in our bounds? Didn't we come up with our bounds? We did, okay? We put them in the equation after we integrated, okay? So that's what we're going to do here. But in our case, if we have the derivative, we go back to the original equation, right? So for us, instead of f's, we don't have f's, we have g, correct? So I'm going to erase these. And if I have g prime, that's like taking g of the upper bound minus g of the lower bound, the original g, not g prime. All right, well, how does that help us? Because, see what numbers go here and here? This is a bigger number, 3. So I'm going to put that here, which means this will be 3. This is a lower number, 0. I'm going to put that here, which also goes here. Okay? So let's set this up with those numbers. I have the integration from 0 to 3 of g prime of x dx should equal g of 3 minus g of 0. They're asking us to solve for g of 3. I don't know what this is. But they give us g of 0. It's 1. Equals the integration from 0 to 3 of g prime of x dx. Man, that's messy. And what is integration if I don't have an equation? It's area under the curve. I'm just getting all loopy. From 0 to 3. So let's take a look at our graph and do something I just can't stand when the board does that. Boom. From 0 to 3. Okay, I have 2 perfect shapes that I just need to know the equation of. This one here is the circle. The area of a circle is pi r squared. My radius is 2, so that's going to be pi times 2 squared. But here's the catch. Starting at 0, I only have a quarter of a circle. So I'm going to multiply that times a quarter. So that's 1/4 times pi. This is 4. Oh, the 4's cancel. That's nice. So it's, yep, I don't know why I'm stuck with zeros in the mind. It's pi. It's pi. Maybe because of the circle. I don't know. I don't know. So for right now, I got to take this area, which is pi, and I got to add it to the area. Oh, I can't use orange. Let's use this. Of this triangle where it stops at 3. The area of a triangle is 1/2 base times height. My base is 1 and my height is 2. 1/2 times 1 times 2. Well, the 2's cancel. That's just 1. All right, so the area of this is 1 and pi. I need to add those together. The area under the curve of all of this, which I'm trying to find for that integration, is pi plus 1. This area under the curve is pi plus 1. That equals g of 3 minus 1. If I'm solving for g of 3, I just got to add 1 to both sides. So g of 3 is going to equal pi plus 2. That's it. That was very, very simple. Once you get past the explanation. If you didn't know the explanation, now it becomes, the algebra is simple. Choice B. 16, let f be the function given by f of x equals x cubed minus 6x squared minus 15x. What is the maximum value of f on the interval from 0 to 6? All right, the maximum value of f. We need to know a couple of things here first. Maximum value means I need to find critical points where my first derivative is equal to 0, because that's the only place that my derivative or slope can change. If I want a maximum, I want a positive derivative or slope followed by a negative derivative or slope, and that only happens at a critical point where our first derivative is 0. And keep in mind, I only want it from 0 to 6. I don't care about anything less than 0 or anything more than 6. I have an interval. So let's first find the derivative of f of x. That would give me 3x squared minus 12x minus 15. Let's set it equal to 0 and find our critical points. Well, I know I have a greatest common factor. I'm going to divide a 3 out of both sides. So I've got x squared minus 4x minus 5 still equals 0. Factoring never goes away. X, why don't we call that minus 5? And x plus 1. Two numbers that multiply to negative 5 that add to negative 4. It's negative 5 and 1. And now, the board, kids, the board. I am going to solve each one. I set each one equal to 0, so x would equal 5. And I take x plus 1 equal to 0, which means x equals negative 1. Now, on my number line, and I'm going to use a number line to visualize this. On my number line, here's my x value and here's my derivative. I know at negative 1 and at 5, I have zeros for my first derivative. Those are critical points. But here's what I want you to understand. Look at my interval. 0 to 6. From 0 to 6. I don't care about this critical point. I don't care about anything on this side. So I really only have one critical point. All right? So what I'm going to do is I'm going to try some numbers in between. Like let's try 1. Let's put that in the first derivative. I can put that right here, or I can put that right here. Let's put it here. Okay? If I put a 1 here, that would be 1 minus 5 times 1 plus 1. That's negative 4 times 2. That's a negative 8. This is negative, which means I'm going to have a slope going down. Let's try the number 6. Okay, let's put a 6 into the same derivative here. That's 6 minus 5 times 6 plus 1. That's 1 times 7. That's a positive. So positive. So it's kind of going up here. So there's a minimum here. This is not a maximum. What does that mean? There's only one choice that I can pick for a maximum. That means these endpoints are both high points. This is a low point. I got to check the y value at 6, and I got to check the y value at 0 and see which one is bigger. Okay? See which one is bigger. Which means if I have an x-coordinate here, and I want the y-coordinate, because this is the value, this is the location, this is where, your x value is where it occurs. They want the maximum value, which means they want the y-coordinate. Anytime I have an x and I want a y, I go back to the original equation. All right, so let's take that equation, throw in a 0 and 6, and see which one is larger. Okay, so f of x equals x cubed minus 6x squared minus 15x. First of all, if I throw a 0 in there, I put a 0 in for everything. That makes everything 0. That's 0. That's my y value at 0. So when x is 0, y is also 0. So at this point right here, the coordinate is 0, 0. Let's try 6. I don't have a calculator. You're pretty smart, kid. 6 cubed minus 6 times 6 squared minus 15 times 6. First of all, if I multiply 3 6s together and I subtract multiplying 3 6s together, that's going to cancel. But that, I believe that's 216. 36 times 6, that's 36 carry 3, 18. Yeah, 216. So that's 216 minus 216. These go bye-bye. So now I just have 15 minus 6, which is 90, but it's negative 90. Ooh. So that means at 6, I have negative 90. Okay, these are my two high points, believe it or not. This is one, which occurs here, and this is the other one, which occurs here. Which one's bigger? 0 is definitely bigger than 90. Negative 90, I'm sorry. So my max value is going to be 0. Oh boy, look at that. The smallest value listed happens to be the maximum value of the function they give us. Tricky. I really dislike question 17. It really just tests you on manipulating a quadratic equation. You know, and I get it. There's an integral too that you're going to have to evaluate. But if you can't manipulate the quadratic, you can't do the problem, which drives me nuts. And I guess that we had to factor. I say factoring never goes away. But the way you got to manipulate this is a way that we hardly do it. I mean, some teachers push this a lot. I don't. Maybe you get pushed more in middle school. That's factorable. But guess what you need to do here? Integrate. All I'm going to do is manipulate my expression in here. I'm not going to integrate yet. 1 over. I'm going to change this 5, so it's x squared plus 4x plus 4 plus 1. Notice I broke my 5 up and just call that plus 4 plus 1. Okay, I pretty much made a perfect square there, which I hate that you have to do that. So this bottom, okay, let's not forget we have a dx, is now a perfect square. I'm integrating 1 over x plus 2 squared plus 1 dx. This is an inverse trig rule. I guess the derivative of x, I guess I'm going to put it. All right. Okay, so whatever x is gets squared. I mean, a lot of times you see a u there, so the u goes here. Okay, in our problem, it's x plus 2 that's getting squared here. So guess what? That means x plus 2 goes here. Oh, it drives me crazy. So it's tan negative 1 of x plus 2. And then I guess you got to do plus c because we're integrating without bounds. And guess what? This is the same thing as saying arctan. Oh, lordy, lordy. It's not arcsine, it is arctan. But this part really gets me that we had to do this. Instead of looking at this and saying that's x, you know, whatever, it's not factorable. I think I said earlier it is. It's not. 1 times 5 are the only thing. It's unfactorable. But instead of trying to do u sub, which you can't do here anyways, like you get stuck, you really got to identify if there's a perfect square within there by breaking up that last number, which, you know, I don't know. There are teachers out there that probably push that, and they're probably so happy to see that. I don't push that style of trying to get a perfect square. I do completing the square and whatnot, but I don't know if you know it. You did it. Number 18, let f be the function defined by f of x equals the cubed root of x. What is the approximation for f of 10 found by using the line tangent to the graph at the point of f at 8, 2? Oh, thank God. Just a regular, normal calculus problem. Okay. We need to use the equation of the line tangent. Okay. That's y minus y1 equals slope times x minus x1. All right. We have an x and a y that are going to go in for x and y1. That's 2. I don't know this yet. That's x minus 8. All right. Slope is the same thing as derivative. Before I take the derivative, I'm going to change this to x to the 1/3. So I got 1/3 x, and I subtract 1 from my exponent, negative 2/3. Since I'm going to have to put an x value of 8 in there, let me just change this a little bit. I'll bring my x to the bottom and make the exponent positive. That's 2/3. And then I'm going to change that to the cubed root of x squared. Now I'm going to plug in my 8. 1/3 times the cubed root of x squared. I'm going to take the cubed root first, which is 2. And when I square 2, I get 4. So that should be 1/12. Okay, and that's going to be my slope. And if I want, I can add 2 to both sides to make this y equals. So y equals 1/2 of x minus 8 plus 2. I need to figure this out. Remember, that's a coordinate. When x is 10, what's my y? Okay, when x is 10, what's my y? Well, let's plug a 10 in here. 10 minus 8 is 2. Half of 2. Oh, that's 1/12. My bad. Plus 2. That's, okay, this goes into here 6 times. So I get 1/6 plus 2. All right, well, I'm going to change 2 into a fraction with a 6 in the bottom. 12/6 is 2. And if I combine those, I get 13/6. All right. Not too shabby. Good one. 13/6. C. 2 more problems. Number 19. The limit as x goes to 0 of 4x squared over e to the 4x minus 4x minus 1 is. All right. The simplest way we can try and solve this, okay, is by substitution. So I'm going to try subbing the 0 in first. 4 times 0 squared over e to the 4 times 0 minus 4 times 0 minus 1. The top is 0. Okay, anything to the power of 0, this is e to the 0, is 1. Minus 0 minus 1. I get 0/0. That tells me I can use L'Hopital's rule. Well, I guess I should do that. Okay, what that tells me is I am going to take the derivative of the top separately, and then I'm going to take the derivative of the bottom separately, and then try and plug my 0 in again. I am not using the quotient rule. Okay, so the derivative of the top is just 8x. Okay, the derivative of the bottom, the derivative of e to the 4x is e to the 4x times the derivative of the exponent, which is 4, minus the derivative of 4x is 4, and the derivative of a constant is 0. Okay, let's try plugging in a 0 at this point. Okay, this is at x equals 0. So I've got 8 times 0 over 4 times e to the 4 times 0 minus 4. Top is 0. Bottom. e to the 0 is just 1. Still times my 4 minus 4. That's 4 minus 4. I still get 0 over 0. So guess what I get to do again? Again, I'm going to take the derivative of the top and the derivative of the bottom. Again, separately. Do not do the quotient rule. Okay, so now the derivative of 8x is just 8. The derivative of 4e to the 4x. Well, I have my constant 4. The derivative of e to the 4x we just did is 4e to the 4x. The derivative of a constant is 0, goes bye-bye. So let's clean this up. We have 8 over 4 times 4 is 16e to the 4x. I'm going to try one more time at x equals 0. This is L'Hopital's rule. If I put in any value in a limit and I get 0 over 0, I take the derivative of the top separately and the derivative of the bottom separately and try it again. If I get 0 to 0, I do it again, take the derivatives. Okay? So the good thing here is the top has no x to put a 0 in. The bottom is 16e to the 4 times 0. This is e to the 0. E to the 0 is just 1. 16 times 1 is 16. That will reduce to 1/2. Wow. Even the limits are a little bit lengthy in this section. Ooh, been here 40 minutes. Wow. It's an average of 4 minutes a problem if you do 10 problems. But we got it. Don't worry. It's worth it. Some of you guys need to hear this stuff. Number 20, and finally, the last problem. Let g be a twice differentiable function, increasing function of t. If g of 0 is 20 and g of 10 is 220, which of the following must be true on the interval from 0 to 10? All right, so this is, we're going to go back to the mean value theorem. Remember there's a problem where we took the instantaneous velocity and set it equal to the average velocity? And I was trying to think, I'm like, is it the mean average, mean value, or average value? No, it's the mean value theorem. I don't know why it hit me now. But the mean value theorem says that in my interval, okay, there's always going to be the derivative at some point, which I don't know, should be equal to my change in y over change in x. And of course here, change in t over change in g of t. Okay, this is the average. All right? So keeping that in mind, I am going to do this with the information they gave me. Because remember, you should always think of these things as coordinates. When x is 0, y is 20. We'll call this x1 and y1. When x is 10, y is 220. We'll call those our 2's. So y2 minus y1 is going to be 220 minus 20 all over x2 minus x1, which is 10 minus 0. So I got 200 divided by 10, which is 20. That is this part. According to the mean value theorem, because we know this is continuous, how do I know it's continuous? If it's differentiable, it has to be continuous. Okay? If it's differentiable, it has to be continuous. Not the other way around. Okay? But if it's differentiable, it has to be continuous. That means that there's some value where I can take the derivative at one point, and it should equal 20. And that, of course, is choice B. That is a complete mean value theorem thing right there. We are done. Thank God. You know what? I don't care that I spent a lot of my time on this. I don't care that I spent 44 minutes. Oh, my God. Instead of 25 or 35. Every once in a while, we get a video that is lengthy because the problems are lengthy. You know what? Even if you watch this video just for one problem, problem 14, I don't know. It's worth it. It's absolutely worth it. Follow me on YouTube, like, ring the bell, leave me a comment if there's a test you want to see. I'll see you later. Bye-bye.
Don't forget to subscribe and ring that bell.